Hi, my name is Dallin Badal. When I go to bed at night, I turn on a fan to keep me cool. Then, when I wake up in the morning, I use an electric toothbrush to clean my teeth. Both of these seem like monotonous tasks, but they are only made possible using a revolutionary invention called the electric motor. Electric motors have become the primary way electrical energy is converted into usable work. What that means is when I plug my vacuum cleaner into the electrical outlet, it is electrical energy that is turning the rollers of my vacuum to clean my floors. Electric motors have countless applications, but they all rely on a fundamental process that utilizes electromagnetic forces. The first step in creating an electric motor is to create an electric magnet. By the laws of electromagnetism, electric current flowing through a wire creates a magnetic field. The polarity or direction of that magnetic field is dependent on the direction of the current flowing through the wire. When the wire is formed into a loop, as shown here, the magnetic field combines to create a north and a south pole. This is called an electromagnet. The electromagnet is allowed to rotate freely on an axle. The second step in creating an electric motor is to surround the electromagnet with a permanent apparatus called a stator. The stator is made of permanent magnets of opposite polarity. They are not dependent on electric energy to create a magnetic field. By the laws of electromagnetism that we knew since we were in kindergarten, opposites attract and like repel. And in the case of our electromagnet, the opposite pole will be attracted to the opposite pole of the stator, causing it to spin clockwise in the way it is represented here. If this was the end of the story of electric motors wouldn't carry us very far, because once the opposite poles are aligned, it would have no more force to cause it to spin. This is why the third step is likely the most important element of creating continuous spin in an electric motor. In the third step, a new element is introduced called a commutator. A commutator is a segmented wire ring, as shown here. Each side of the commutator is attached to one end of the electromagnet loop. The commutator is attached to the power source using wire brushes. These wire brushes rub continuously on the commutator ring as the electromagnet spins. As you'll notice, the wire brushes are in contact with only one side of the commutator. This allows electric current to flow in only one direction through the electromagnet ring. As you'll remember from when we were making the electromagnet, the polarity of the electromagnet is dependent on the direction of the current flowing through the wire. Using the commutator, when the wire brushes cross over this gap, they suddenly come in contact with the other half of the commutator ring. This inverts the direction of the current flowing through the wire, and therefore inverts the polarity of the electromagnet. This is shown here, where the north pole was on the left side, but then when the wire brush crossed the commutator gap, it became the south pole on the left side. Now suddenly, the like poles are very close to each other and experience a very strong magnetic force that cause it to continue to rotate. This creates a continuous cycle where the like poles will repel, causing it to spin, and then when the opposite poles come close to each other, the commutator inverts the polarity of the electromagnet to cause it to continue to spin. Finally, more loops can be added to the electric motor to increase the torque of the motor. This makes it more applicable for large-scale projects such as electric cars. So next time you go in your electric vehicle, remember the electric motors that are getting you where you need to go. Thank you.